You've seen them, right? Those absolutely jaw-dropping, vibrant images from deep space. You know, the pillars of creation, all those swirling nebulae. They're gorgeous for sure, but they're also secret messages, written in a language of light and chemistry. So the real question is, how in the world do we translate them?
The James Webb Space Telescope. It's our detective out in the field. It's gathering all these cosmic clues from billions of kilometers away. But, a detective's only as good as their crime lab. So, how do you analyze a fingerprint that was left behind in a gas cloud 1,000 light-years from here? Well, the answer, believe it or not, is right here on Earth, in this pretty incredible facility in Heidelberg, Germany. It's officially called the Cryogenic Storage Ring, but I like to think of it as our interstellar waiting room. It's the one place we can go to recreate the universe's quietest, coldest corners, so we can solve its biggest mysteries. So what is this thing exactly? The CSR is basically a 35-meter particle accelerator, a giant ring. But its real superpowers are the two extremes it combines: unbelievably cold temperatures and a vacuum that is, get this, emptier than deep space itself. This is what lets it trap and study individual molecules for a really, really long time. In this contrast you're looking at, this is where the magic really happens. See, in a normal lab here on Earth, the molecular world is a total mosh pit. It's hot, it's crowded, it's chaotic. Molecules are just smashing into each other billions of times a second. But inside the CSR, it is the exact opposite. It's cold, it's empty, and it is perfectly, beautifully calm. Molecules can just fly around for minutes, maybe even hours, completely undisturbed, just like they would in some icy nebula out between the stars. Just how cold are we talking about? The entire machine is cooled down with liquid helium to a mind-blowing 6 Kelvin. That's minus 267 degrees Celsius. That is colder than most regions of interstellar space. Just ridiculously cold. And the vacuum? Oh, this is my favorite part. It is so perfect, so incredibly empty, that a single molecule inside could, in theory, travel the entire distance from the Earth all the way to the Moon without bumping into a single other thing. That is the insane level of isolation we're talking about, and it's the only way to really hear what a single molecule has to say.
So why go through all this trouble? Well, it's all about getting a molecule into what you might call its Zen mode, and that is the key to everything that comes next.
At room temperature, a molecule is basically like a toddler on a massive sugar rush. Seriously, it's just a frantic bundle of energy. It's vibrating, it's spinning wildly on its axis, and it's constantly crashing into its neighbors. And in that chaotic state, it's just impossible to get a clear read on what it really is.
But inside the CSR, all that chaos just melts away. The extreme cold and the perfect quiet force the molecule to shed all its extra energy. It stops spinning, it stops vibrating, and it just settles into its lowest possible energy level, what scientists call its ground state. It becomes perfectly still. And only then, only when it's totally calm, can it reveal its true, unique signature. So the process itself is actually pretty elegant. First, they trap charged molecules, or ions, inside the ring. Giving them a little electric charge just makes them easier to handle. Second, the environment does all the work, isolating them, calming them down into that Zen state. And third, with the molecule finally quiet, scientists can interrogate it, using super precise tools like lasers to read its unique signature.
And all of this leads to the ultimate payoff. This is the moment the CSR truly becomes the universe's premier forensic lab. This is how we crack the case of those cosmic messages.
Okay, so picture this. You're an astronomer, you're using the James Webb Telescope. You point it at some distant, super colorful gas cloud, and what you get back is a spectrum of light, this pattern of bright and dark lines that looks kind of like a barcode. This is your evidence. This is the cosmic fingerprint. The problem? You have no idea who or what it belongs to.
And that's where our lab comes in. Back in Germany, scientists can take a specific molecule they think might be out there, stick it in the ring, cool it down to its Zen state, and measure its perfect, unmistakable light signature. What they create is a flawless reference fingerprint.
And then you get that incredible aha moment. They compare the reference from the lab to the evidence from space. And if the patterns line up, boom, it's a match. Case closed. The CSR is essentially building the fingerprint database that allows astronomers to say with 100% certainty, hey, that mysterious signal from 1,000 light-years away, that's a complex carbon molecule, a potential building block of life. Without this lab, a lot of Webb's data would just stay an unsolved mystery. But this whole thing isn't just about looking back in time and identifying old molecules. The CSRE is also a critical proving ground, helping us build the tech we need for the next wave of space exploration.
The stuff they're learning here directly helps design future missions. We're talking about better molecule tasters for our Mars rovers, or more advanced instruments for probes going to check out the plumes of icy moons like Enceladus. It's even helping develop ultra-precise clocks for deep space navigation. Heck, they can even create and study spook molecules. These are highly unstable compounds that exist in space but would fall apart instantly in a normal lab. It's just wild stuff.
And just to give you a sense of the mind-bending engineering we're dealing with here, get this. When they cool the machine from room temperature all the way down to 6 Kelvin, the entire 35-meter steel structure actually shrinks by several centimeters. This means the engineers had to intentionally build the ring too big, calculating perfectly so that it would shrink to the exact right size once it was ice cold. It's just an absolutely incredible feat of engineering.
So when you boil it all down, the CSR is our translator for the cosmos. It turns these mysterious signals into known chemistry, and that leaves us with a pretty profound thought. We now have proof that the fundamental building blocks for life can actually form in these incredibly cold, empty voids between the stars. Which really, it makes you wonder, if that can happen out there, what else is waiting to be found in the universe's quietest corners?